Welcome to the Explainer. Today we're doing something a little different. We're not just going to describe a fundamental particle. No, we are going to build one from scratch, using what you might call a recipe for reality itself.
But first, let's start with a puzzle. I want you to imagine a ball in the middle of a room, and it's connected by a bunch of ribbons to all the walls. Now, if you start spinning that ball, what's going to happen? Sooner or later, you're going to have a hopelessly tangled mess. So how can a fundamental particle, which is woven into the very fabric of space-time, spin forever without tying the universe in a knot?
Well, the answer isn't brute force. It's actually a kind of beautiful, continuous reshaping of the universe's fabric. You can think of it like a topological dance, where every twist elegantly untwists itself in this perfect repeating cycle. And that is the incredible secret we are unpacking today. So how do we solve this cosmic tangle? Well, the first step is to shift our thinking. We need to stop focusing on just what particles do and start engineering a real blueprint for what they actually are. You see, for a long time, physics has been absolutely brilliant at coming up with mathematical descriptions for how particles like fermions behave. But that leaves this huge question on the table. What is a fermion, physically? I mean, what's its actual structure? That's the gap we are trying to fill right now. To build anything, you need raw material. So this next part is all about the foundational stuff we're going to use to build our particle, the very fabric of reality. Okay, so forget about thinking of reality as tiny hard points. I want you to imagine that the universe is this continuous, flexible, and elastic medium. Everything that exists isn't an object sitting in this fabric. It is a shape made of this fabric. This is our starting point. Now, this fabric isn't just a free-for-all. It's governed by 4 really strict rules. First, diffeomorphism. That means no tearing, no knotting. Second, elastic resistance. It can stretch and snap back. Third, the no-crossing rule. No part of the fabric can phase through another. And finally, there's a tension driver, which is like the engine that powers all the reshaping. Let's focus on the most important rule here, diffeomorphism. You can think of this as the golden rule of topology. You can stretch, you can bend, you can reshape this fabric all you want, but you are absolutely positively forbidden from ever tearing it or tying it in a knot. This one rule is what ensures the universe remains a single, unbroken whole. Okay, so we've got our material and we've got our rules. The next step in our little recipe is to take a piece of this fabric and start shaping it into the basic structure that's going to carry all the properties of a particle. And this is a really crucial point. The particle we're building, it's called a resonance carrier ball, or RCB. It's not like a marble sitting on a rubber sheet. It is the rubber sheet, just locally reconfigured into this incredibly complex ball-like shape. So let's look at the actual architecture on this slide. To get the behavior we need, a simple sphere isn't going to cut it. You have something called a unique point that sucks in the surrounding fabric, and that creates an axis of symmetry. Then that flow is guided by this really complex internal geometry called a horn torus. You can picture it like a donut-shaped vortex tucked away inside the sphere. And this slide just illustrates the whole concept brilliantly. Over on the left, you've got the simple blueprint, right? You see the axis, the unique point at the bottom, the direction of the flow. But then on the right, that's a render of what this complex dynamic structure might actually look like. It's literally a localized storm in the fabric of reality. We've built the house. Now we need to install the engine. How do we get this static structure into a state of continuous, non-tangling motion? Well, the answer is a beautiful piece of topological engineering. This quote from the source really gets to the heart of it. The motion isn't a rigid rotation like a spinning top. It's a constant, smooth reshaping, almost as if the fabric were made of all these interconnected belts. Think of a Balinese dancer whose arms and hands can move in these intricate ways, but never actually get tangled up. And here it is, in action. As that central cube rotates, the fabric connected to it twists. Yeah, but it also reshapes and flows around itself in this perfectly coordinated sequence, so that after a full cycle, it's ready to go again with 0 knots. This is the belt trick, and it's the engine of our particle. All right, we have our structure and we have our engine. Now we get to the most profound, the most mind-bending consequence of this entire recipe. This is the part where the model connects directly to one of the absolute strangest properties in all of quantum mechanics. So think about this. If you spin a basketball on your finger 360 degrees, It's right back where it started. Simple. But this machine we've built, it is not simple. After one full 360-degree rotation of that central core, the surrounding fabric is still twisted. The system has not returned to its original state.
To get everything, and I mean the core and the surrounding fabric, all the way back to the starting line, the core has to turn not once, but twice. A full 720 degrees.
And here's the kicker. Normal objects, the ones that reset after 360 degrees, are what physicists call spin 1. But particles that require a full 720-degree rotation to get back to normal, those are called spin 1/2. This isn't just some random label. It's the defining characteristic of fermions, the very building blocks of all matter. This model doesn't just assume this property, its very geometry creates it.
And there you have it. By combining the architecture of the resonance carrier ball with the dynamics of the belt trick, what you end up with is a complete recipe, the physical machinery that behaves exactly like a fermion.
But the implications here go even deeper. Properties that we think of as fundamental, like mass and energy, they aren't separate things. They simply emerge from this geometry. Mass isn't something the particle has. It's a direct measure of the total volume of fabric used to build its shape. And energy? That's just the vibration and resonance of that shape. This quote really drives the point home. Physical properties aren't some mysterious add-on. They are direct consequences of the particle's topological engineering. What a particle is determines what it does. And that leaves us with this one final, kind of mind-bending thought. If the fundamental building blocks of matter are nothing more than these incredibly complex, self-sustaining shapes in the fabric of reality, what other aspects of our universe are just geometry in disguise? What else are we mistaking for an object when it's really just the dance?